Hello and welcome back. We're continuing our discussion this week on exceptional testing with discussions of test doubles. So this will be our first introduction to test doubles such as dummies, stubs, fakes, and mocks. And then this conversation actually kind of continues throughout the weeks as we add more layers of complex testing onto our projects. So let's first just sort of discuss this idea of a test double, what it is and why we might want to use it, right? So sometimes when we're trying to run tests with our code to make sure our code works, the connections that we sort of rely on might be very slow, but we don't actually need them to test the behavior, right? So when we're writing a unit test, we don't need the real file system. We don't need a real database. We don't need like an API for Slack, right? Like we don't need that real connection to be alive and working to test whether or not smaller individual units of code that we wrote are working. So using something as a test double would allow us to sort of extract out those slower connections. There's also this idea that maybe parts of our code are a little bit risky to be running in test scenarios. So if you send a confirmation email to a test account when you are submitting something successfully while you're running hundreds of tests, maybe you don't want to send yourself 100 emails, right? Maybe we're deleting data. We don't want to delete real data, stuff like that, that we don't actually want to see happen. Or maybe we're making network calls and those will incur charges and we don't want to do that while we're just running our tests. Which kind of actually leads me into this idea of what's expensive, right? So if we have really slow and risky and energy, time, and network consuming behaviors, it can start to be expensive both time-wise and like financially expensive. Our continuous integration pipelines can get bogged down. Our machines can take a really long time to sit there and run. If we can't use our machine while we're running a test to check if our code is working, that's a problem. One of my favorite comics is actually this one here where it says the number one programmer excuse for legitimately slacking off, right? My code's compiling. Get back to work. But for real, developer time is expensive, and if for some reason we're unable to continue working because our code is running, we're trying to test our code, we can't make additional changes till we know if what we did worked, and it takes a long time, it's expensive financially, it's expensive for energy, it's expensive for time. Like we can see why this can sort of be a bottleneck for our project. So being able to run tests quickly and effectively without compromising their stability or their credibility is a really good thing to be able to do. So the solution is this idea of test doubles, right? So basically, like I said, they're fake collaborators that we can control for testing. They replace these very real dependencies with safe, predictable ones and allow us to test the behavior that we want to be testing without any real side effects and without compromising the test or the behavior of our code. It makes us have this additional ability of testing things quickly, keeping our tests isolated and reliable, right? They become very deterministic because we aren't relying on another system to, send that email, make that payment go through successfully, whatever it might be. This allows us to keep things really nice and isolated. Basically, all can be summed up right here. I don't need a real jet engine to test the flight controls in a simulator, right? We can test that these are real things, that they might work without actually burning fuel in a jet engine. There's other things that we can do. If they use the same software, I don't need the physical jet engine to test the controls. This is just going to be an intro to test doubles. We're going to talk way more about advanced techniques later. We do in our code for now use kind of a simplified database, which is why it feels important to discuss it now. But just know that this conversation, like I said, is going to continue in later weeks as well. So there's a bunch of different test doubles here. There are dummies, stubs, fakes, mocks, and spies. So there's 5 that we talk about in this class. I have some columns here of what it does and a column of the example usage as well. But we're not going to really talk about all of these right away. We'll probably just focus on these 3 for today. And these ones we'll discuss at a future point in time. I might talk a little bit about mocks at the end, but very little. So we can see here that dummies are passed in but never used. basically just this idea that a method signature requires something, but we don't actually need it to test the unit of code that we're using. So we might use some kind of dummy just to sort of placate the system. Stubs always return a fixed value. So it would be sort of like implementing a class where you called get role, and get role would always return admin. So stubs are usually implemented on like an as needed basis for specific testing suites or specific pieces of code you're trying to test. Fakes are the one that we're already starting with because our database is a fakey database right now. Basically it works, but it's simplified logic. So it allows us to test behavior without actual dependencies on anything. We fake a database connection by making a fake database made out of array lists in our code. Then we have mocks and spies that verify if things are working and record things as well. Record calls, record like parameter calls, not like phone calls. And record like, it basically is like spying on a piece of code and checking in to see if the things are working as intended. But again, we'll see those later. Like I said, we're focusing in on fakes because that's our database. In our code right now, we use a fake database in iteration 1. And as part of iteration 1, when we're writing our unit tests, we can use our fake database, but we also might find ourselves using a stub. So you may hear people refer to the database that we use in iteration 1 as like a stub database. It's a stub/fake. We kind of use it in both ways. The fact that it's going to basically be a bunch of array lists or hash maps in our database file makes it a fake. But we often call it a stub database as well. So just keep that in mind if you hear me sort of mix up those words, or if you see any sample projects that have the word like stub user database as opposed to fake user database. The point being it's just array lists. Okay, so here's just a quick little summary of them all. Dummy, needed for the method, but completely irrelevant, like needed for the method signature. Stub is answering questions. What is the role? You're going to give them back admin. Fake actually does something, but very simple. So no database connections, no reliance on transactions, none of that bottleneck that gets created. But it does hold data in it because it's an array list. A mock will confirm that something has happened. So you have the ability to use this mock to actually ensure that certain calls were made, that certain tests were checked in on, things like that. And then the spy will confirm what has happened and with what. So sometimes these are often interchanged or used together, mocks and spies. We can confirm something happened and then use a spy to make sure that what happened is what we expected and with the right pieces. So like I said, in our iteration 1, we're going to start with fakes and stubs. Because they're the easiest to implement without a proper framework, such as like Mockito, which we will see in iteration 3. You also might find yourself using some dummy data as well, some dummy objects. So let's talk a little bit about swapping our test doubles into our code. So when we think about our code base, we probably have some kind of a front end. We have our logic and we have our persistence. And when we run a test, we have our test, we have our service, and then we have our database. The test is going to call into the service, and the service probably depends on the database. But when we're running our test, this can be slow and risky. We can't always control it. We don't know if we're going to have the right connections. In the real world, it wouldn't all be necessarily living on our single machine. And we don't want to rely on whatever production uses, right? Like we want to be able to isolate and quickly test a piece of service code rather than service and database mesh together. Okay, so what are we going to do? We're going to make some kind of fakey database. Now, in the real world, like the reason why we start with a fakey database in this course is even though your fakey database in iteration 1 is also your real database for now, for iterations 2 and 3, that fakey database lives on. You switch to a real database, but your fakey database becomes something that you can use for tests. So we are starting with this idea of a fakey database in the real world in our project. But for a second, I want you to try to like separate it out in your brain that the database in your project, in your iteration 1, is real. Okay, it's real. Because while we are not doing a proper connection just yet, I want us to treat it as if it's the production one, because it is for iteration 1. Now, on the other side, when you write your unit tests, you're going to want some kind of fakey database that is not your real database, real, fakey database that's not your real database so that you can access your objects and data without any connection to what is considered your real database. This will be fast, predictable, and safe. So since, like I just said, we're going to move on to really proper, nice looking swapping in iteration 2, but I'll still show an example of what I mean right now for going test to service, allowing that isolation of it in just a minute. We're not testing our database. Our unit tests test logic. They test behavior. We're not testing a database. We want to know how our service behaves when the data comes back in a certain format or with certain data. So we can just remove that dependency. We don't need it. So how are we going to do this swapping? Let's do an example of this. We're going to use interfaces. So what we can do is we can make an interface for our database that outlines the behaviors in which we plan to use. One goes to our real database, and one goes to our test database. So even if your real database connects to HDB SQL, even if it's NoSQL or MongoDB or SQLite, whatever it might be, that real connection knows the behavioral endpoints that it needs to connect to thanks to an interface. And the fakey database that you're going to use for your test suite, your testing database, has those same endpoints because they're both going to implement the interface. Let's take a look here. Here is our public class real sender, and it's going to implement some interface that we created called email sender. Email sender, that interface has like one method in it, a void send method with those 3 parameters. So this would be inside of our interface. When real email sender implements this interface, it has to do something here. So what's it going to do? We're going to connect to an SMTP server based on the information inside real email sender inside this class. And then we're actually going to send the email based on the to and the subject and the body, and we can send an email out. However, this is not safe for tests. We could spam random people. I'm sure somebody out there has a fake123@gmail.com email address. So when you type in this fakey email address, if you do it in your real database, you might accidentally email somebody. Yes, it's on them for making that their database or their email address name, but we're going to be good people. We're going to try not to spam them. This is going to need some kind of configuration file, right, for that SMTP server configurations to set up that email address, to set up all that information. When for a test, it's possible we just don't care about any of that. Maybe we're just testing to make sure that the string body isn't empty, right? We don't need to really send an email to test that. But maybe the way our code is set up, it would, in theory, validate that it's a valid body and send the email. This also could be slow from all those connections and flaky. If the SMTP server is down, if other pieces are missing, we're relying on things that we just don't care about for a potential test. So we take that interface and what do? We make a stub or a fakey email sender that also implements the same interface. And now this one no longer sends it out into the real world. Instead, the send is going to just add the email you're about to send into a list of emails. It can print out, email was sent to so-and-so successfully, and that's it. And now if we're going to go and test that the body actually was what we needed it to be, we can inject this class in. We can call .send email from the service layer. The service layer can now connect to the email sender. The email sender is the stub in this situation instead. And now we're not really sending any emails. There's no actual side effects here, right? So some of your database classes in iteration 1 are going to look exactly like this. In iteration 1, you might not even have an interface. Although I recommend it, it isn't required, but I recommend it because you'll need it for iteration 2. Most of them are going to look fakey, not stubby, because you're not returning predetermined data the way that a stub would always be like the same deterministic value. It actually does the behavior of a fakey database because it's an array list or a hash map or whatever it might be. But they're okay. Both of those situations are totally okay for iteration 1. So what this means is if all you need is a stub because you only have one user and there's no way to log in, so you have a stub database that always returns the same username and the same user password, that's okay. And if what you have instead is the possibility to make users, but you just need to store every user created somewhere, so you just store it in an array list, for now, that's also okay as a fakey user account database array list. So hopefully that makes sense. You can sort of see how we can make stubs or fakey databases. Both are okay for iteration 1. So when we're talking about test doubles, we did talk about some of the reasons why test doubles are important at the very beginning of this. So let's talk about the best use cases then for using test doubles. When we have to connect to databases, web APIs, third-party services, right? Sending emails, Slack, maybe we have a built-in Slack for our project. We have our databases. These slow or external services can really slow down our test scenario, can cost us money to query the database if we don't own it, right? Like that could cost us money, like real money, not just like time spent, which is also real money, but So when we use a test double instead to fake out that space, it makes it fast and local. If we are accessing an API, we know the endpoints, we can implement our own version of it that we use for testing that has the same endpoints that I don't really care about if I'm just testing my service layer. I can just ignore those API endpoints are going somewhere real. We also know that some services could have side effects. It could overwrite files or send emails or make network calls or process payments. None of those things are things that we want to happen when we're running our test suite over and over and over again. So instead, we use stubs or fakes to simulate our data safely, right? We can simulate the effects of the service without actually doing those effects. And lastly is this untestable interfaces, right? So sometimes there are just hard to control collaborators. If you use the time class, the random class, some hardware things, there are just some things that we cannot easily control. But allowing ourselves to use test doubles in certain situations will allow us to then inject the predictability that we need to test the functionality we want. We're not trying to test that random definitely returns a random time or a random number, but perhaps we're using random to simulate a dice roll. We still want to simulate a dice roll, but we don't want to have to rely on the unpredictability of random. So having the ability to inject these through the use of interfaces is immensely helpful. If you're currently sitting here thinking, how would you do that? Just because I know random is a built-in class and your brain might not be where mine is right now with that, basically what you would do is you would make a wrapper class, and then in your real implementation, you would just basically have a random number simulator inside. And so your wrapper class is an interface, random wrapper, whatever you want to call it. Make a real one that uses the random built-in random class, and then you can make your own for testing purposes that is a stub and always returns 5 or whatever it might be, right? I don't know, just picking a random number. But we can see how we can wrap it in an interface, wrap it in a class that would allow us to then sort of piece out the pieces as we need them. So test doubles give us that speed and control and confidence without having to depend on any of the real world chaos that kind of exists around us. Now, I know I said this is coming in iteration 3, but I will just mention very quickly this idea of mocks and this framework called Mockito. We will go into it more. If you're going to skip this part of the video, there's still a pause and reflect, but hopefully you'll quickly just look at it with me. It's really neat. We can see here that if we're going to use mocks instead, we can sort of remove the need for creating stubs or fakes, because mocks can fake them on their own. It's very powerful. You don't need to write your own stubs anymore. You have very precise control over behavior and very clear verification of interactions. So if we mock up an email sender class, this basically makes an object that's fake. It makes it all without us having to actually write any of the code. We can also even say that when our sender calls the method send with any field values here, anything in here, anything in here, anything in here, and any of the parameters, then return true. And we've stubbed it. We're always returning true on send now. We didn't have to write like a full faked or stubbed version of email sender with every single method that the interface requires. We didn't have to do that. We were able to just make this quick little empty shell mock and just say, if somebody calls .send, then return true. And then all we would do is in our test, once that's part of like our setup, right? We have our arrange, our act, and our assert. This is our arrange. Here we've got registering a user for us to actually run this code. We made some service.register user so that we can use it in our code that we're testing, whatever that service piece is. And then we have our act/assert here. We're going to verify that when we call mock send with any data that we come back with true. Right? So really all we're doing is verifying that the data is going in and true is gonna come out. It's possible that instead what we want to do is verify the email or verify the to or the from or whatever it might be. We can see that this is supposed to be the to, this is supposed to be the subject, and this is supposed to be the body. And if we want to sort of write tests around those pieces specifically, perhaps there's like a service level that needs to interact with this. That will allow us to like further deepen the placement of this mock and still test out those pieces. I will show an example of it come iteration 3, but I just thought it would be neat to sort of have an opportunity to know where this is going, which is a very, very powerful framework that we don't need yet, but we will use soon. Now, sometimes this is a better option because it allows us to have some real-ish behavior for some pieces, but not for other pieces. And we can use stubs when we only care about return values. We can use our fakes when we want some behavioral endpoints. And then we can use our mocks when just the interaction of data is the point. Like we don't care about anything else. The thing is that we don't want to always use mocks because there's a lot of overhead that happens under the Java hood with mocks that maybe we just don't need. So the general rule of thumb in the real world is you don't mock what you don't own, which means we're using mocks to test things like API calls and third-party software that we're employing. In our projects, you've written everything, so you will be mocking what you own, but that is sort of the general rule of thumb in the real world. All right, so at this point in time, you can pick one recent test that you wrote, because you've hopefully been writing some tests, and ask yourself, how would you improve it using a test double or even maybe some better assertions? You can do this with something that you wrote yourself, or you can pick one recent test that a team member wrote and ask the same question. This way you can share your answers in the next meeting and potentially improve upon the things that you've been doing. Maybe it means making some interfaces and wrapping some classes up. Maybe things are looking really good, but it's a really great place to talk with your team about how to ensure you're sort of testing your code in a effective and stable manner. Cool. So thank you so much, and I will see all of you in the next video. Thanks. Bye.